been on a little bit of a mission lately, and primarily this was driven because in the UK at the moment it's kind of hard to get modelling supplies. They kind of just don't really seem to be around. So the first problem I hit was I had a new gas plane and I just couldn't get hold of the spinner that I needed that would fit. So well, I thought, can I 3D print a spinner? Now, you know, the simple answer is yes, but in practice, and this is a big practice thing, gas models, petrol models, any kind of four-strokes, anything like that, you know what, we don't fully appreciate just how much of, you know, kind of a hit these things take. Every time that engine ticks over, it's kind of almost a bit like the plane, everything is almost being hit with a small hammer. Just bang, bang, bang. And, well, that starts happening at however many RPM, and you find things don't go so well. So, I've kind of gone through a few iterations to try get something to work. Now, I'll kind of give you an idea what I've got here. So here is, this is a little 9cc gas engine, which I created a spinner for, and this one is actually built out of ColorFab N-Gen, which is a little bit like a PET-G filament. And you can see here, it's quite a decent looking spinner, it fits, it does the job. But, you know, so I did a version for this to run on one of my 25cc motors, and well, it was sitting there idling along, and this all of a sudden went pop, and the spinner fell off and broke into about 5 pieces, which was a bit disappointing because at that point of the game, I kind of thought that actually all the force is not going to be, you know, I was thinking centrifugal force and the spinning breaking the thing apart. I wasn't thinking about the fact that every time this engine ticks over, there's this shock wave that gets it. So, yeah, I didn't have much luck. But what I did is I decided, well, the logical step is to try a different filament. And the one that came to mind immediately was Ninja Tech Armadillo. Now, Armadillo is an interesting filament. It essentially allows you, I guess it's almost nylon, but not. It's very hard, very abrasive. It's a hard TPU rubber. So it's like, imagine all the strength of rubber, but in something that's hard. And the result we have is this. So you can see it's quite a sort of matte type finish on it. And it's ridiculously strong. Ridiculously so. This sort of thing just does not break. But, yeah. So my logic to this was that because it's a rubber, each associated bang that we get, there's a little bit of absorption within the material because the rubber doesn't try to stay put, it just goes with the motion a bit, is the best way of explaining. So I thought, well, let me try a spinner like that. But it did introduce another problem. So my back plate in this case, let's show you here, the back plate, you can actually see the compression that has happened on here. And the problem there is that when you're tightening the back plate against the motor, you're getting more and more compression, and you know, well, it's rubber. What does rubber do? It compresses. So the end result is that I found my back plate was getting distorted, which was kind of mangling things up. Now, what's happened in the end, I've gone for kind of a bit of a hybrid situation. So I modified my designs, and I think it's probably best I show you this online. So if we look at Thingiverse, which there will be a link below this video taking you to this design, essentially we have the spinner, which kind of, let me see if I can go into 3D mode. There's the spinner, and you can see it's all kind of nice and thick and got bolt holes and supports and all sorts of things on it. That then has a back plate. Oh, go to 3D mode again, and you can see the back plate, and what I actually want to draw your attention to is this area here. So this area is effectively a key, and the idea I had was, let me print all of this outer area in Armadillo, because Armadillo kind of takes the hit. But encased within that, we have this little key. Now, the idea behind this key is it's really just to hold the main spinner in place, but it's also printed in something like either PLA or PET-G or ABS, something really, really hard with no compression. So the idea is that when I tighten the nut of the prop up against this, that it collides with the very hard object that we have here, which stops the backplate distorting. And the end result is all of these sort of 3 items plugged together, and off we go. Now, the eagle-eyed of you will notice there's 4 items here, and I've got 2 backplates. Well, the reason's quite simple. If we look at this backplate 1, we got a straight hole in it. And the other backplate has a hex sort of shape in it. And the reason is that you might want to use a nut to secure the front to the back, or you might want to use those little brass sort of like grip collar things that they use in 3D printing. And that's kind of what I've done here. You can see these little brass sort of threaded inserts that go in. And, well, I find I prefer the brass one. You know, you can't kind of turn a hexagon into a round, if that makes any sense, too easily. So when that goes in, it's fixed and it works. Now, printing this, because it does work, first off, on the Thingiverse, you will notice over here there is an option, where is it? Open in Customizer. So, this is a completely parametric OpenSCAD file. So what this means is if you wanted a spinner that was 80 mils in size, you set the diameter 80, you generate and you get an 80 mil. And kind of all the parameters like the prop width, the prop height, the hole at the back, how, you know, do you want 4 of these, well, the angle of these disperse apart, I suppose, for these screw holes, all of those can be done via the parameters inside OpenSCAD. So the result is you can produce kind of anything. And I guess that's the classic example. 2 different spinners, both produced with exactly the same OpenSCAD file, and it kind of works. So, yeah, that's step 1. You can make a spinner to suit the size and design of your model. And number 2, you really want to print the backplate and the sort of front spinner. Armadillo, nylon if you got it. Nylon would be bloomin' fantastic, but Armadillo so far is holding up and showing that it does the job. And you want to print the washer in something like PLA or PETG. And then it kind of just works. Now, the big caveat to all of this, and again it's a big caveat, I have tested this so far on a 25cc NGH motor. I've not tested it on a 4-stroke yet. I will be, but 4-strokes do have a little bit more of a, you know, a bang. So what I don't know is kind of how much of a hit this will take as it gets bigger and bigger. So certainly a 25cc 2-stroke is working at the moment. The 9cc's and things we'll take as, yes, those can work, probably the 10s and 15s because they're all smaller. I don't know about bigger. Also, very important, I'm printing at 100% infill on everything. So the idea here is to make this as solid and as strong as possible. Now, what I'm not going to bother doing, but maybe someone else wants to, and I'd advise wear some eye protection and all that sort of stuff, maybe printed an ABS and acetone bath or something would be interesting and kind of bind and fuse all the layers. But I'm not convinced about that. I think the problem is more, you know, if you look at commercial spinners, or I don't have one floating around, but a commercial spinner, they're generally always made out of nylon, the plastic ones. And the reason is nylon has that kind of ability to really flex and take the bangs which hit it. So Armadillo is the closest easy filament for me to print. And it is very easy to print and it's incredibly durable. So that's what I'm using. But yeah, there you go, guys. Maybe you want to try it out yourself. I will put a link for the spinner down on the Thingiverse page in the description below. Let me know how you get on. Cheers, guys.